The German technician traced the contours of the American armor with a gloved hand. A distinct sense of unease settled upon him. The machinery felt disturbingly precise. The fault lay not within the machine, but rather with the preconceived notions regarding American industrial capabilities. The calendar read April 1943. Resting within the Kummersdorf testing facility, this particular unit had been seized in Tunisia merely 2 months prior. It bore the serial designation USA 3,067,641. Its original crew had christened the vessel War Daddy 2. The German High Command demanded a comprehensive technical assessment. Their objective was to expose the Sherman's vulnerabilities, specifically requesting ballistic charts that pinpointed the precise coordinates for a fatal strike. For 3 weeks, the engineer had scrutinized every nut and bolt. Yet instead of frailty, he discovered resilience as he inspected the seams of the steel. These connections were not merely robust, they were immaculate, consistent, and clearly the product of automation. It was not simply the manufacturing doctrine that instilled fear. It was the dawning comprehension that while the Reich labored over individual mechanical masterpieces, the United States was essentially photocopying instruments of war. War Daddy 2 had fallen into German hands on February 22, 1943. This occurred 8 days following the commencement of the Battle of Sidi Bouzid, an engagement that had proven catastrophic for the American forces. German panzers had collided violently with the 1st Armored Division, forcing a chaotic withdrawal toward the Kasserine Pass. This specific machine was assigned to Company G 3rd Battalion 1st Armored Regiment. Amidst the disarray of the retreat, its operators were compelled to leave it behind. Perhaps the fuel tanks ran dry or a lucky strike severed a track. The official archives remain silent on the matter. Historical documents confirmed that German recovery units discovered the Sherman completely undamaged. Furthermore, in a rare turn of events for captured hardware, the engine ignited upon the very first attempt. The captors navigated the vehicle over 200 miles to Tunis, a grueling journey spanning 4.5 days across the arid sands. Suffering neither breakdown nor mechanical fatigue, it was subsequently hoisted onto a transport vessel bound for the fatherland. High Command insisted that their most elite engineers dismantle the prize. The discoveries made by those technicians would fundamentally alter their perception of the conflict. Kummersdorf stood as the premier facility for weapons evaluation within Germany. Situated 20 miles south of Berlin, this site served as the cradle of rocketry and the proving ground for every significant Wehrmacht weapons system staffed by the Reich's finest minds. Having assessed captured Soviet T-34s in 1941, they were instrumental in designing the Panther as a strategic countermeasure. Confronted now with their first American medium tank, their initial anticipations were notably dismissive. Intelligence reports had cast the Sherman as a substandard product of mass manufacturing, possessing inadequate armor and weaponry constructed by a nation inexperienced in modern armored warfare. The technical team approached the specimen with the haughty demeanor of master craftsmen critiquing a counterfeit. They anticipated haphazard welding and fragile metallurgy, fully prepared to ridicule this crude American attempt at engineering a machine of war. Their fountain pens were poised to compose a blistering critique intended to please the upper echelons of command. Commencing with the protective plating, they measured each section and calculated the angles, stenciling the data directly onto the hull in stark white paint. The depth of the armor proved sufficient, though it failed to inspire awe. It measured 51 millimeters on the anterior hull and 38 on the flanks. A Tiger tank could penetrate such defenses from over a mile away. Then they unlatched the engine compartment. The Continental R975 radial engine rested in the rear chassis, resembling an aircraft power plant transplanted into a tank precisely because that is what it was. The United States had repurposed a reliable aviation engine for use in armored combat. It boasted 400 horsepower and air cooling engineered for dependability at altitudes where repair was impossible. The German observers immediately noted the power-to-weight ratio. While the Sherman tipped the scales at 30 tons, the engine provided 13 horsepower for every ton of weight. In contrast, the 45-ton Panther equipped with a 700 horsepower engine achieved only 15.5 horsepower per ton, scarcely surpassing the smaller American vessel despite being 50% heavier. Yet raw output was not the source of their admiration. Any industrialized nation could construct a powerful motor. What truly struck them was the accessibility for maintenance. Every critical component was reachable through generously sized hatches. Replacing the oil required mere minutes, and spark plugs could be swapped without specialized equipment. A mechanic possessing only elementary training could maintain this engine indefinitely. Conversely, German armor necessitated the attention of factory-trained specialists for even routine service. The Maybach HL230 found in the Panther was notorious for cooling failures that frequently resulted in catastrophic engine fires. Replacing such a unit demanded a heavy crane and a full day of labor, whereas the Americans had engineered a vehicle serviceable in the field by virtually anyone. Germany had created machines that required return shipment to the assembly plant. As the engineers continued their inspection, their anxiety only deepened. It was the acoustic signature, or rather the absence thereof, that gave them pause. Upon engaging the powertrain, they anticipated the screaming whine of spur gears battling friction. Instead, the Sherman simply hummed. Disbelieving his own ears, one technician summoned his colleagues to witness the core's herringbone gears. These were precision-cut helical teeth that interlocked seamlessly under pressure, the type of engineering designed to endure thousands of miles without faltering. German armor relied on spur gears featuring straight-cut teeth, an economical choice that unfortunately crumbled rapidly under the intense strain of battlefield maneuvers. The rationale behind this decision was straightforward. Producing herringbone gears demanded sophisticated machining and specialized cutting instruments that were largely absent from the German inventory. Such tooling relied on tungsten carbide, a critical resource choked off by Allied naval blockades, forcing Germany to fall back on spur gears to conserve production hours and extend the life of their machinery. Conversely, the transmission within the Sherman proved capable of enduring 3,000 miles of operation before requiring a major overhaul. In stark contrast, the final drive of a Panther typically failed after a mere 100 miles, not 100,000, but simply 100. While a Sherman possessed the endurance to traverse the distance from Normandy to Berlin, unassisted, a Panther struggled to complete the brief journey from the railhead to the combat zone. Although the technical staff meticulously recorded these findings, they remained wholly unprepared for the revelation that awaited them. Mounted upon the 75mm cannon was a modest enclosure from which electrical leads extended to a gyroscope situated near the gunner, revealing a sophisticated gun stabilization mechanism. The American forces had successfully integrated a gyroscopic stabilization system into a vehicle manufactured on a mass scale. This discovery left German engineers dumbfounded, as their own attempts to miniaturize such components for armored warfare had consistently ended in failure. The level of precision demanded by such a device exceeded the limitations of their manufacturing infrastructure. To be fair, the Westinghouse design was not without its flaws, providing stabilization solely along the vertical axis. While it did not permit firing while in motion with modern accuracy, it offered an advantage of significantly greater worth. The system maintained the barrel's general alignment during movement, allowing the gunner to discharge a precise shot mere seconds after the vehicle halted. German armor required 10 to 15 seconds for the suspension to stabilize before accurate aiming was possible, a critical delay in tank duels where the victor is often the one who lands the first blow. The Sherman could deliver that decisive strike before its German counterpart had even ceased its oscillation. Upon scrutinizing the gyroscope and servo motors, the Germans attempted to calculate the resources necessary to duplicate the system. The conclusion was undeniable. Replication was impossible given their deteriorating industrial-based scarcity of materials and lack of precision manufacturing. Yet the most disheartening revelation was still to come. In June of 1943, the vehicle known as War Daddy 2 was transported to Hillesleben for a presentation before the High Command. Their interest lay not in a reliability trial, but in a spectacle drawing senior officers from across the Wehrmacht to witness the event. These were the generals who dictated armored production priorities, the very men responsible for deciding whether to persist with the Tiger and Panther programs or to chart a new course. The organizers constructed a climbing challenge featuring a steep 30-degree slope of shifting sand, with the Panther selected to make the initial attempt. The German machine ascended the incline with apparent ease, its broad tracks gripping the loose terrain while its formidable engine performed without strain. As the generals exchanged satisfied smiles, it was time for War Daddy 2 to prove its mettle. However, its narrower rubber block tracks, intended primarily for road travel, lost purchase on the unstable surface, causing the engine to whine and the tracks to spin helplessly as the tank slid in reverse. The Sherman proved unable to conquer the slope of failure that elicited applause from the assembled generals. The display confirmed precisely what they desired to believe. Yet this failure at Hillesleben was indeed a catastrophe not for the Americans, but for the observers. It was in fact a calamity for the German war effort, though the generals gazed upon the hill and perceived only a triumph. The engineers, however, examined the transmission and recognized a dire warning. While the Panther had won the sprint, they understood it would inevitably fail the marathon. Although the Sherman could not ascend that particular sandy incline, it had recently traversed over 200 miles of the Tunisian desert entirely under its own power. That was an achievement the Panther could rarely match without shattering its final drive. The climbing test merely served to validate every erroneous instinct held by the German military establishment. It persuaded them to continue manufacturing high-performance thoroughbreds rather than investing in reliable workhorses. The technicians who had spent weeks analyzing the engine compartment of War Daddy 2 understood the reality, yet they stood by as their commanders cheered the sight of the Sherman sliding backward down the sand. No one wished to acknowledge that the American tank's inability to climb the hill was insignificant compared to its success in reaching the testing grounds in the first place. Eventually, Albert Speer arrived to inspect the situation personally. As the Reich Minister of Armament, Speer held absolute control over German war production. Every tank aircraft and submarine constructed within Germany fell under his jurisdiction, and he was renowned for his ruthless efficiency. Through rigorous reorganization and streamlining, he had successfully tripled the nation's weapons output during 1942. He maintained a firm belief that with proper management, German engineering could outpace Allied production, and photographs remain of him closely examining War Daddy 2. After studying the reports and consulting with the engineers, he reached a conclusion that would haunt him for the remainder of his days. Speer later recounted in his memoirs that field reports from Italy were full of praise for the Sherman's cross-country mobility. The American tank proved capable of scaling mountains that German experts had deemed completely inaccessible to armored vehicles. The engine provided a nimble agility on flat terrain that the heavy German behemoths simply could not match. Yet Schaar perceived a far more profound strategic dilemma. The German Reich was constructing intricate mechanical marvels that remained tethered to the railway lines for transport. In stark contrast, the United States was assembling a truly autonomous force capable of motoring directly into the heat of battle on its own power. It became clear to Schaar that even the pinnacle of Teutonic engineering could not surmount a superior logistical doctrine. The Sherman represented something far greater than mere steel and weaponry. It embodied an entire industrial ethos, a distinctly American philosophy grounded in three non-negotiable pillars. Dependability, ease of repair, and volume of production stood in direct opposition to the singular German obsession with absolute technical supremacy. The designers in Detroit and Ohio made calculated trade-offs, opting for a modest 75mm cannon because it offered unfailing reliability and utilized ammunition that was in abundant supply. They knowingly sacrificed the thickness of the armor plating, prioritizing a lighter chassis that allowed for exceptional maneuverability across the battlefield. By embracing mechanical simplicity to ensure rapid assembly and effortless field repairs, they created an operational tempo that Germany was utterly unable to rival. The failure lay not in a lack of brilliance among the German engineers, but rather in the tragic reality that they had directed their genius toward the wrong objectives. The true scholars of this disparity were not the draftsmen, but the tank crews themselves, such as Alfred Rubbel, a Tiger I commander in the 503rd Heavy Panzer Battalion. Earning the status of an ace with 57 confirmed victories, he possessed an intimate knowledge of exactly where the capabilities of German armor began and ended. His unit frequently repurposed captured Shermans for recovery missions, leading Rubbel to liken the American tank to a dependable family automobile. One simply pressed the starter and the engine roared to life, whereas the Tiger demanded a rigorous and delicate pre-start ritual. After checking fluids warming the engine and fretting over the delicate transmission one might move, the Sherman conversely simply performed. While German crews held a deep affection for their Panthers and Tigers, that admiration was reserved for the rare moments when the machines were actually functional. By the year 1944, German armored divisions were reporting abysmal operational readiness rates ranging between merely 35 and 45%. At any given moment, more than half of their fleet lay dormant awaiting repairs, while American units consistently maintained a readiness standard exceeding 85%. Simply put, When the Americans required armor for an advance, the vehicles were present and ready for duty. The raw data revealed a narrative that the German propaganda machine desperately attempted to conceal a reality laid bare during the campaign in Normandy. That specific theatre of war vindicated every apprehension previously held by the astute engineers at Kummersdorf. During the withdrawal from France, nearly 50% of all abandoned Panther tanks were scuttled by their own crews following mechanical failure rather than enemy fire. One can scarcely imagine the profound exasperation of a German crew possessing the most lethal cannon on the field. They were encased in the thickest, most impenetrable armor plating ever devised. Yet there they stood, stranded on a French roadside, watching their transmission billow smoke while an endless parade of technically inferior Shermans rolled past them to claim victory. Their defeat was not a consequence of being overpowered in combat, but rather the result of an inability to arrive at the battlefield in the first place. The statistics emerging from the Battle of the Bulge were even more dire, with non-combat causes accounting for 60 to 70% of heavy tank losses by late 1944. They fell victim to empty fuel tanks and fractured gears, rather than American ballistics, a catastrophe the Kummersdorf engineers had predicted as early as April 1943. Those experts had attempted to look beyond the theatrical hill-climbing display presented at the proving grounds. They sought to focus on the essential elements, the internal mechanisms, the philosophy of fabrication, and the unforgiving mathematics of durability. They had meticulously catalogued every logistical benefit the American tank design brought to the table. Their reports lucidly explained why the American model of mass production would inevitably triumph in a war of attrition, yet their warnings fell upon deaf ears. The High Command observed the Sherman struggle on a single sandy incline and departed with an arrogant confidence in the supremacy of German engineering. Unfortunately, Germany was incapable of adopting the American manufacturing ethos for reasons that extended far beyond blueprints and mechanics. Essential strategic resources were non-existent, and the creation of herringbone gears demanded sophisticated tooling that the nation simply did not possess. Advanced electronics required copper and rare earth elements materials that the Allied naval blockades had effectively severed from the German supply chain. Furthermore, the manufacturing culture was too rigid to adapt. Their factories relied on master craftsmen who painstakingly hand-fitted each individual component. In contrast, American facilities operated with interchangeable parts and highly efficient automated assembly lines. Transitioning from one system to the other would have required years that the Reich did not have, and the prevailing Nazi ideology proved to be an insurmountable obstacle. Since German engineering was touted as unrivaled, acknowledging the superiority of American mass production techniques would have contradicted the regime's core belief in Aryan exceptionalism. Consequently, the nation persisted in the production of the Tiger tanks. They continued to churn out Panther's magnificent beasts of war that spent significantly more time undergoing repairs than engaging the enemy. These engineering marvels simply could not contend with the overwhelming tide of American quantity and steadfast reliability. Germany remained ensnared, bound by a doctrine that demanded absolute perfection while possessing an industrial base that could no longer sustain such luxury. By the war's end, America had manufactured 49,324 Shermans, while Germany managed only about 6,000 Panthers and 1,347 Tigers. The disparity in industrial output was stark, approaching a ratio of 8-to-1, specifically regarding medium armor. Furthermore, American vehicles functioned flawlessly upon reaching the vanguard. While a solitary Tiger might vanquish 5 Shermans in a single skirmish, by the following sunrise, a fresh half-dozen Shermans would appear on the horizon. Meanwhile, that formidable Tiger would sit immobilized, languishing for a replacement gearbox that would not materialize for 3 weeks. The arithmetic of this conflict was unforgiving. Indeed, the German crews secured combat statistics that would have guaranteed victory in any other era. Yet the outcome of this struggle did not hinge upon tactical scores. Rather, it was decided by the immense power of logistics. The machine known as War Daddy 2 demonstrated to the German designers precisely why defeat was inevitable. Here was a vehicle that roared to life the instant one engaged the starter. Clear's throat. It possessed a drivetrain built to endure as long as the hull itself, and a power plant so straightforward that any general technician could maintain it. Dependability triumphs over flawlessness. Presence outweighs mere potential. In the end, a functioning machine conquers a superior one on every single occasion.